Hey guys, today in this video, I will explain you the workflow of the 3D character games. Will take you into a tour giving you insights of every steps which is included while making a 3D character. My name is Nishant and I'm a game artist working in games, and I'm here to share my knowledge, whatever I have learned in last 1 year. So let's get started. So before jumping into steps of making a game-ready 3D character, let's talk about what exactly a 3D character is. 3D character is a digital representation of a living being or an object created in 3D space. Unlike 2D images, which is a flat and has no depth, a 3D character has volume which can be viewed from any angle. This makes them more realistic and immersive, and they can be used in variants of application including video games, movies and animation, special effects and virtual reality. Now guys, you have an idea what exactly a 3D character is, and it can also be known as CG character, or CG stands for computer generated. Now let's talk about the workflow. The first step is modeling. This step includes the modeling the base mesh for the character. Steps in this is modeling base first, then adjusting forms and overall shape of the body. Both male and female has different kind of forms, so it is modeled by step. Since body has a lot of details like muscles, skin details like pores, wrinkles and body hair. So how to start modeling the base mesh? So there are two ways to do this. First is blueprint modeling. Taking help of the blueprint and modeling every part of the body part by part by extruding faces and joining them together. In this you will have to take care about the topology of the mesh, and overall you have to take care about the polygons, especially when you are modeling for the video game. After base mesh is ready, then you can move with the muscles and forms and other details. The second method is using sculpting. In this, you move with sculpting the mesh using digital clay, sculpting the muscles and details, etc. Now next step comes is retopology. This step is very time consuming step and it's very crucial. In this, literally you model the model once again. Which the difference between sculpting and retopology is sculpting destroys the topology of the mesh and contains high poly count, because sculpting minor details requires plenty of geometry or polygons, which makes model very dense and it cannot be used in games or movies. So after sculpting, we retopologize and recreate the model. But in retopology, we create a good topology and that will be used. Also, to make your retopology less time consuming, there are some auto retopo add-ons which will make your model code based in few seconds. For example, like instant remesh or quad remesher. But if you're a beginner, ignore auto retopo. First understand manual retopology and how to keep blue flows in right direction and make quad based topology. Now next step is UV unwrapping. This step includes unfolding the mesh and converting the 3D mesh into 2D image. This is a very important step for texturing. Unwrapping will tell the software where my texture needs to be placed. It can also be done automatically or manually. For example, Blender has a feature called Smart UV Project, which simply means auto unwrap. But this is a bad feature because it will generate lots of UVs of various sizes and will be difficult to maintain. But if you need to just model and add textures, then you don't have to export this model to any 3D program, and this feature is very useful. But if you want to export this to any other 3D software, for example game engine, then you have to need maps, and for that you need to unwrap it manually, and manual unwrapping is preferred, so ignore auto unwrap. So next steps comes baking. So in the realm of 3D, baking has a separate meaning that differs from traditional kitchen activity. It refers to a process called texture baking, which essentially captures detailed information from one 3D model and transfer it to another 3D model. And usually it is in the form of 2D texture maps. But you guys might be thinking, why baking is done? So there are few reasons why baking is done. First is this improves performance. Baking allows you to use a low poly model for real-time rendering, while retaining the visual complexity of a high poly model through the big details. This significantly improves performance and reduces the resource usage. Next is enhanced realism. Texture baking can capture intricate details like shadows, lighting effects and surface imperfections from high poly model and bake them onto a low poly one. This adds depth and realism to the simpler model and make it appear closer to the original high poly version. Next is streamlines workflows. Baking can save you time and efforts by reducing the need to manually paint all the details onto the low poly model. This is particularly useful for complex objects or scenes with intricate lighting. Fourth is improved frame rates and lower rendering cost. Low poly models with baked textures render faster, making them ideal for applications like games, and real-time applications. Fifth is more realistic visuals. Big details enhance the visual quality of the low poly models, making them indistinguishable from their high poly counterparts in many cases. Now let's talk about types of baking. First is normal map baking. Transfer shadings information like surface bumps and crevices to maps, creating realistic lighting effects even on low poly model. Second is ambient occlusion baking. Captures subtle shadows and occlusion in crevices and corners, adding depth and realism to surface. Third is curvature baking. Bakes information about a model's surface curvature, which can be used for various effects like baking subsurface scattering or adding wrinkles to cloth. Even in simpler terms, you can say it highlights the sharper edges. And also similarly, you can bake other maps like roughness map, metallic map, displacement map, specular map, subsurface scattering map, diffuse map or albedo and emission map, and etc. But point to be noted, all maps depend on the type of model you are making. For example, if you're targeting a sci-fi model or the hard surface model, then probably you will be using a diffuse map, roughness, curvature and metallic. Now after baking, next comes texturing. Texturing in 3D is the part of adding visual details and depth to a 3D model, essentially like dressing up a bare mannequin to bring it to life. Software used for baking are Substance Painter, Blender and Marmoset Toolpath. Here's how it works. Creating textures. First is photos. Real-world photos can be used as textures. Second is procedural textures or PBR texturing. These are generated algorithmically, creating repeated patterns like bricks or fabric wave. In simple terms, PBR texturing is simply computer generated. Everything is generated in software itself using the node. Third is hand-painted textures. Artists can directly paint textures onto a 3D model surface, ideal for unique or stylized visuals. Everything from shadows, highlights, color, everything is painted by hand manually. Fourth is hand-painted PBR, which is a blend of PBR and hand-painted texturing. Texturing is done in layers. All required maps are baked first. Main maps are roughness map, metallic map, normal and albedo, also known as diffuse, then ambient occlusion map and cavity map. These steps are done in mainly PBR workflow, which is very common in AAA games. Hand-painted texturing requires painting knowledge, creativity and your artistic skills. Such as Substance Painter, 3D Code, Blender offer tools for texturing. Even Photoshop is also used. Now comes the juicy part of the 3D. That is lighting. Lighting in 3D plays a crucial role in bringing scenes and characters to life. Similar to how lighting sets the mood and atmosphere in a film, play is not just making things visible, it's about creating depth, highlighting important elements, and guiding viewers' attention. Keep in mind, lighting is a complex subject and differs from model to model and environments to environments. For lighting a 3D character, 3-point lighting is very common. Next is rendering. Rendering in 3D is the process of transforming a 3D model into 2D image or animation. It's like taking a virtual photograph of a 3D scene, capturing all its intrinsic detail, lighting and material, shadows to create a visually stunning and realistic representation. Point to be noted, rendering and compositing subject is important for a VFX artist, not a game 3D character artist. Don't confuse with games and VFX. So that's all for the video. I hope now you have a clear-cut idea on what goes behind the 3D character creation. So if you find this video helpful, don't forget to leave a comment below. And if you liked it, subscribe the channel and hit the like button. And in what topics you guys want to see the video, please don't forget to comment that also. So see you in the next video with a different topic.